Hi everyone, welcome to this video. In this video, we'll be mainly covering the network services that is offered by AWS. So we'll see how you can create your own virtual network using the service that is VPC. Then we'll see different types of subnet that you can create such as private subnet, public subnet. Also, we'll see how you can do VPC peering, that is you can peer different VPC, or we'll cover the transit gateway, route tables. We'll also see security groups, VPN, site-to-site VPN, direct connect, or we'll see the endpoints also, VPC endpoints. So in this session, we'll cover all these services. So we'll see the significance of these services and how you can use these services in your design or in your environment as well. We'll cover how you can do a cross-account communication between two AWS networks using these, or if you want your on-premises data center to communicate with AWS, then how you can set up that thing. So we will mainly touch upon all the networking part in this video. So please stay tuned to this video and it is gonna be very interesting and informative session. Thank you. So let's start this video now. Suppose you want to deploy a application in AWS, and for that purpose, you need to create some EC2 instances for Lambda functions, and there is some database requirement as well. So in order to create all these resources, you need to have the underlying network layer, that is the VPC. So there is a default VPC that comes along with your account. You can use that or you can create your own VPC. Let's start with creating a VPC. Suppose this is my VPC and I have a CIDR block associated with this. With this VPC, if you want to create an instance, EC2 instance, you cannot directly create an instance in VPC. So in order to create instance, you need to create a subnet inside it. Let's say this is my subnet, subnet 1. So for this purpose, I'll create, let's say, two subnets inside the same VPC. So in both these subnets, I can host my different application. Let's say if I want to have some level of segregation between application, I can host application 1 in subnet 1 or subnet 2, or I can host some application in subnet 1 and databases in subnet. So it is totally dependent on you, like how you want to configure your application, and it is up to your design. So these are two subnets as of now, and currently the configuration is same for both the subnet. So let's move to the next thing. So the question that arises is that now we have a VPC and couple of subnet, but how can these subnets talk to each other? How the traffic flows? Like, do we need to do some configuration for that? For that purpose, we need to define some route tables. So the next thing that I'll be covering is the route table. So route table basically, here you need to define some routes that determine where the network traffic will flow. So as soon as you create a VPC, there is a route table that is associated with that VPC. That is the main route table. So that is associated with your VPC, and your subnets are associated with the main route table. So that is a setting that is already there. But let's say there is a different routing requirement for subnet 1, and for subnet 2 there is a different routing requirement. So in that case, you can create your own custom route tables, and you can attach different subnets to it. So you can attach different subnets to different route table. It totally depends upon your traffic or networking requirement. So with the main route table, there is a route that is added by default, that is the local route. Let's say the VPC CIDR block is having this range /16. So there will be a local route in the route table that will having a destination of your VPC CIDR block, and that is this in this case, and the target will be local. So what it does, like it allows you your traffic within the VPC to flow. So that means because your VPC is having this CIDR block and target is local, so that means you need not to do any specific configuration within your VPC to communicate to different subnets. So the traffic will flow. So this is the local route. So as I said, there's a main route table comes with the VPC. You can create different route table or custom route table based on your requirements. So all these things you can do. So let's say I'll just clear some of these. So let's say I'll attach a route table here, and let's say this is my route table one, and I'll attach a different route table to my other subnet. So this is the route table. Let's say we have installed some applications in these subnets. So in my subnet 1, I have installed my application 1, and in subnet 2, there is one application as well. Okay, but there's a slight difference between these applications. The application which we have in subnet 1 needs to connect to internet. So it works with internet access, and people are also connecting to this application from internet. That is a requirement, but app 2 is an internal application that is accessible only inside my VPC. So that is its purpose. But app 1 is slightly different and it needs the internet access. So just a point to highlight here is that by default, your VPC does not have any internet access. Like if you have created a new VPC, but with the default VPC that comes along with AWS, there is an internet gateway attached. So I'll just quickly cover internet gateway, what it is. But if you are creating a new VPC, there is no internet gateway. So mainly if you want your application to connect to the internet, or the other way around, that if people from internet can connect to your application, then you need to have the internet gateway attached to your VPC. So the next thing that I'll be covering is the internet gateway. So I'll just add internet gateway here. So it is at the VPC level. So this is my, let's say, internet gateway. Internet gateway. So this now I have added to my VPC. Okay. So what it does, or basically, first of all, what it is. So basically, it's a horizontally scaled and highly available service, and it allows the communication between VPC and the internet. So the main thing that it does, that it allows communication between VPC and the internet. So that is its main purpose. It supports both IPv4 and IPv6 protocols. With internet gateway, resources that are on the internet. So let's say this is internet. I'll just draw it. So this is the internet. So with internet gateway, people from the internet can communicate to your app via the internet gateway. And the traffic can also flow from your app to the internet. So this is the two-way traffic that can flow via internet gateway. So with the internet gateway, resources on the internet can initiate a connection to your resources that are in this subnet 1, let's say. But there is slight change or configuration that we need to do at the route table, because you have seen previously we have only one route, that is the local route. But now in order to talk to the internet, the traffic must flow from the internet gateway. So we have to update our route table 1 that is associated with subnet 1 with another route, something like that. So if my traffic is, or the destination is internet, then the target, let's say this is the destination, then the target should be my internet gateway. So here my internet gateway, let's say IGW. So this will be my target. So if we add this route in our subnet, so if there is a destination that is this, the traffic will flow to the internet gateway. So the flow will be like this. But your route table for subnet 2 is different, so that will still be fine. So this subnet cannot initiate any connection to internet, or from internet, nobody can initiate a connection to your subnet as well. So with this internet gateway attached, now as per terminology, now this is my public subnet because it is accessible from the public network, and this is my private subnet. So with this thing, my public subnet can talk to internet, and from internet, some people can initiate a connection. But private subnet, nobody can initiate a connection, and from private subnet also, we cannot initiate any connection to the internet. But there is a requirement that we want our private subnet to talk to internet, but not the other way around. That means we want our private subnet to talk to internet, but the other thing from internet, we do not want that. Do not want connection to private subnet. So if that is the requirement, let's say we want subnet. So if that is the requirement, then there is another service that AWS offers, that is the NAT Gateway. So NAT Gateway, first of all, is created or hosted in public subnet itself. I'll just realign these things basically. I'll make some space. So this is the NAT Gateway. So NAT is basically network address translation. So with NAT Gateway, instances in the private subnet can connect to the external services outside your VPC, but the external services cannot initiate a connection with those instances. So how the traffic flows here, from your private subnet, the traffic will go to NAT, and NAT gateway is already hosted or deployed in the public subnet. So here you can see that the traffic will be routed from this subnet to the internet gateway. But for this purpose, we need to add a route in my route table too, that says, if I just copy this thing, if the destination is this, then the target here in this case will be my NAT gateway ID. Okay, so that will be my target here. So what I'm telling, if my private subnet wants to talk to the services outside VPC, then the traffic will flow to NAT gateway, and from NAT it will, via internet, it will go to the outside. But the other way around, that means from here to here, let's say via internet gateway, this is not possible. This is not possible. So it is only a one-way communication from private instance to the internet gateway. But the outside services cannot initiate a connection. So I'll clear some. Before moving to the next service, if you are liking this content and if you are finding the value in what we are doing, so please do consider subscribing to this channel and drop a like on this video. Your support means a lot to me, and that will keep us going. Thank you. So let's move to the next service. So let's move ahead and cover some of the important security services that comes in your VPC. So we have seen that what route table is, but does it mean that anybody from the internet can access the application one? Is there any mechanism that we can control who can access the applications at subnet level or at the instance level? So definitely there are some services available. So the first thing that I'll be covering here is the NACLs, or these are network access control list. So I'll just add a NACL here. So this is what network access control list. So in NACLs, you can allow or deny any specific traffic. So with NACL, you can allow or deny any traffic. You can define your inbound and outbound rules here. That means what traffic can flow in or what traffic can go out, and you can allow or deny based on your requirement. So this is associated at the subnet level. So you need to associate a NACL at the subnet level. Each subnet in your VPC must be associated with a NACL. If you do not associate any subnet explicitly, then it will be associated with the default network access control list. Another important point to note here is that a subnet can only be associated with a single NACL. So that means a subnet can be associated with single NACL, but single NACL can be associated with multiple subnets. Subnet 1, subnet 2. So that means multiple subnets can have same NACLs. So I have added an NACL here and I'll add a different here because I want different set of traffic to flow between my subnets. So as we have seen that NACLs are at the subnet level, but there is another important service or the feature I would say that is the security group. So the significance is that suppose in this subnet you have different applications and you have allowed the traffic via NACL to this subnet. So that means that all the traffic that is coming via NACL can access all the application. But do we really need this? Because I have multiple applications here. Let's say these are my different application, and the audience for these applications are different. So in order to control the traffic at EC2 level or ENI level, we have something called security groups. So let's say I'll create a EC2 instance. Let's say this is my EC2 instance, and I'll attach a security group to this. In order to do this, let's say I'll put my EC2 instance in this. So, and let's say this is my security group. So what does security group does? Like it controls the traffic that is allowed to reach and leave the resources. Security group again, it has inbound slash outbound rules. But with security group, you can only allow the traffic. You cannot deny a traffic. Security groups are stateful. What does that mean? If you send a request from your instance, let's say I'm sending the request from my instance to say this point A. So if this point A reply, then that traffic will be allowed to flow to the instance, even if it does not have any inbound rule defined. That is statefulness. Till now, we are considering a single VPC in our environment, but there can be a scenario where you have multiple VPCs. Let's say this is another VPC in your account, and you have one more VPC that is there in another account. So let's say this is VPC C and this is VPC B and this is VPC A. And you have created some resources in each of these VPC and you want to route the traffic between these VPC. And for that purpose, you need to set up the peering connection. Let's say I have set up this peering connection between VPC A and B. Similar way, I can set up a connection between VPC A and C. So this is the peering connection. With peering, it allows you to route the traffic between VPC. You can create the peering connection between two VPCs, your own VPC or VPC in another account as well. Once you have done the peering connection, then resources such as EC2, Lambda can communicate with each other cross VPC using the private IPs, and it does not require any gateway or VPN connection at all. With VPC peering, it uses the existing infrastructure of a VPC, and the traffic never transverses the public internet. It always stays on the global AWS backbone. So that is the very important point of VPC peering. Another thing I like to highlight here is that here you can see that we have done VPC pairing between A and B. So the traffic will flow between A and B. Similar way, the traffic will flow from between A and C as well. But since there is no direct peering between B and C, so there will not be any traffic flow from bit A and C, not even via from B to A and A to C. So in case you want the traffic to flow from B to C or C to B, you need to set up another peering connection between these. Suppose you have created some S3 bucket in your environment. Say this is the S3 bucket and you want to access the data from it. So usually the traffic flow will be like that. Like the traffic from your subnet or your instance will go to internet gateway, and from internet gateway it will go to internet, and then from internet it will go to the S3 bucket. So the traffic will go via internet to access the bucket. But in case there is a requirement, let's say you want to access the bucket from a private subnet where you do not have that internet connection at all. But in case you want to access these services privately without going to the internet, then there is a offering from AWS that is called VPC Endpoint, and that allows you to access these services privately, and it does not require any internet connection at all. Let's say I'll create a VPC endpoint here. So there are two types of endpoints. One is the interface endpoint and other is the gateway endpoint. So let's say I'll mark it as VPC endpoint. Let's say this is my gateway endpoint. And similarly, I'll just create, this is my interface type. So interface endpoint is a collection of one or more elastic network interfaces. So interface endpoints create ENIs in your subnet if you have created some endpoint of that type. And gateway endpoint use a route table for routing of traffic. So mainly for gateway types, you have only two services. One is S3 and other is DynamoDB. So DynamoDB and S3 are the two services for which you can create the gateway type endpoint. And for other services, you can create the interface endpoint, such as you can create interface endpoint for CloudFormation, API gateway, or SQS, SNS. So you can create different type of interface endpoint. Let's say this is my SQS. I can create, let's say, for another for SNS as well. So with these endpoint, the traffic will not go via internet. It will go from your VPC endpoint to S3 directly. I'll just make it green to DynamoDB. Say, in similar way, from your interface endpoint, the traffic will go to SQS and SNS and to other services as well. So there is another important concept or the service that is VPC endpoint service. Suppose you have created a load balancer in this VPC. So suppose this is a VPC and you have created a load balancer here and you want to access that from another VPC. Suppose from here. So either you can do a peering, or the other way is that you can create a endpoint service in this account. Let's say you can create endpoint service here, and you can create a endpoint in this account using that service. In this way you can access this, and this VPC endpoint service is being powered by private links. Hope you are able to understand the networking components and their placement and in what scenario we have to use what. So there is another service that is coming from AWS, that is Transit Gateway. I'll just mark it as something else. Transit Gateway. With Transit Gateway, what you can do, you can connect all your VPC to the Transit Gateway and can define the routes and the communication will happen. So with Transit Gateway, let's say I can connect this VPC, I can connect this VPC as well, this VPC, and this VPC as well. So now I have connected all my VPCs to the transit gateway. So that means we do not need these individual peering connection and the traffic can be routed via the transit gateway. So basically transit gateway you can use to interconnect all your VPCs, and it is capable of connecting the on-premises network as well. So till now we have seen different components in the AWS itself. Like we have created VPC, subnets, we have seen what routable can do, NACL, security groups, and we have seen the endpoints like allows you to access the services privately. We have seen peering between VPC, and you have multiple VPCs or some on-premises as well. You can use transit gateway. So another important part that I like to cover is here is that let's say we have our on-premises network as well. So this is my on-premises network, and I want my on-premises to be connected to the AWS cloud. So for that purpose, there are multiple offerings for from AWS. Let's say first I'll just quickly touch upon is the direct connect. So basically direct connect is the dedicated connection from on-premises network to one or more VPC. So in order to set up the direct connect gateway, you need to have the virtual private gateway here in your VPC, and similar way you need to have the customer gateway in your on-premises network. So this is customer gateway, and you can set a direct connect connection between these. This thing you can do direct connect between virtual gateway and the customer gateway, and it is a dedicated connection between on-premises and your VPCs. And there is another way you can connect your on-premises network to the VPCs via VPN. And here, let's say we are connecting site-to-site VPN. So with site-to-site VPN, you can create an IPsec VPN tunnel or connection between your remote network and the AWS VPC over internet. So compared to direct connect, that was a dedicated connection, but with this site-to-site VPN, it is a tunnel over internet. And for this purpose, again, you need a virtual gateway and a customer gateway as well. And you can set up a site-to-site VPN between these. So you can set up like this. So there are certain differences between direct connect and site-to-site VPN. With direct connect, you establish a private connectivity between AWS and your data center, and it is an alternative to using the internet to connect to AWS. And your data will be delivered to AWS using a private connection. It does not go via internet. And all these services such as EC2, VPC, S3, DynamoDB can be accessed via or can be used via direct connect. But in case of site-to-site VPN, it is an encrypted connection or a tunnel created between your VPC and your on-premises network over the public internet. That is the main difference. And as I said earlier, that you can connect these direct connect or the site-to-site VPN via transit gateway as well. So you can anyway set up a connection between these, let's say direct connect and site-to-site VPN. You can connect, so you can connect direct connect. Just add a box here, let's say site-to-site VPN to the transit gateway as well. So mainly transit gateway can connect one or more VPC. It can connect direct connect gateway. It can connect another transit gateway as well, or you can connect site-to-site VPN as well. So on a high level, I want to cover all these services networking component, and I want to show how you can use in your design, or in case you are creating or deploying some resources, you can use these endpoints for privately accessing the services. You can use peering if you want your VPCs to talk to each other. You can use internet gateway for accessing internet. All these things I want to cover in this video. And if you like this content, then please do subscribe to this channel and drop a like on this video. And that means a lot to me. Thanks for watching this video.